Unit 1, Section 1, Rates of Change. 1.1.1, Relations and Functions. If f of x equals 10x minus 2, find the value of f of 3. So we simply just plug in 3 for x. So f of 3 is equal to 10 times 3 minus 2. F of 3 is equal to 30 minus 2. So f of 3 is equal to 28. Given this function, so this is a function, it's just listed as a set of points instead, find g of 0. So they're basically saying if x equals 0, what is the y value? And so we look here at this point, 0, 3. If we're looking at g of 0, that is going to be equal to 3. Didn't need to write that there. So g of 0 is equal to 3, just by looking at the point. Find v of c plus 2. So if v of t is equal to this, and they want me to find v of c plus 2, what I need to do is take c plus 2 and plug it in for t. So v of c plus 2 is equal to c plus 2 squared plus 5, which gives us c squared plus 4c plus 4 plus 5. I just FOILed this or used the box. You can do it either way. C squared, 2c, 2c, 4. And so that gives us c squared plus 4c plus 9. So v of c plus 2 is equal to that. State the domain of the function in the figure. Okay, so domain is all of the x values that are covered. So I'm going to go to one of the points on my graph, and then I'm going to draw to the x-axis. So that's 0, and at 0 it has an open circle. And then like all of these would be covered by my graph if I squished it onto the x-axis until I get to 16, which is a closed circle. So the domain here would be x such that, so the lower value is 0, right? If I had this just as a regular line, it would look like this. And this would be 0, and that would be 16, and then my line would go on infinitely in both directions, and this is the shaded part of my line, be between there and there. So 0 is less than x, which is less than or equal to 16. That's one way you can write it. Another way you could write it would be by doing 0, oops, that's a shaky parenthesis, by doing 0, right? We're not including the 0, comma, 16, and then bracket because we are including the 16. State the domain and range of this function. Did it ask for range on this one? Oh, it did. It wants range too. Okay. Sorry. All right. So let's go back. I'm going to go ahead and erase the blue here. And now we're going to find the range. I'm going to do it in pink. So I'm going to start by going all the way over to the y-axis. The first number I hit is 4, and we're including it. And then I'm getting all of these numbers all the way down to 32, which I'm not including. So the range essentially is this line, where negative 32, that's the smaller number, so that's going to go on the left. And negative 4 is the bigger number, that'll go on the right, and I'm shading everything in between negative 32 and negative 4. So our range is y such that negative 32 is less than or equal to, less than, because it's open circle, y, which is less than or equal to negative 4. Close the bracket. Another way I could write it is parenthesis, negative 32, comma, negative 4, bracket, because I'm including negative 4. All right, domain and range again. So domain, I'm looking for all the x values. So if I look on the left, I'm starting at negative 4, and I'm covering all of these values infinitely, right? So if I was going to draw this as a circle, as a line graph again, I would color in negative 4. I'm just going to throw a 0 on there. But it's really everything to the right, because it goes on forever. So that would be x is greater than or equal to negative 4. And we would write that as the domain of x such that x is greater than or equal to negative 4. Another way you could write it is a bracket because we're including -4, and that's the lower number, comma, infinity, parenthesis, because we never include infinity. All right, and then the y value. So I'm going to go to the bottommost y value, which is here, also at the -4, which is 0 on my y-axis. So I'm going to put a closed circle at 0. And then I'm going to go this way, and I'm covering all the points. And I can see that this graph is going to go up infinitely. So again, my line is going to go from 0, which is the lowest value of the y, not -4 because that's the x value, 0, y value, and it's going to go on infinitely. So I'm going to color in the circle, and y only gets bigger throughout my graph. So this would be y is greater than or equal to 0. So my range, y such that y is greater than or equal to 0. Or I can write it in bracket notation, interval notation, sorry, from 0 to infinity. Find the zeros of the function f of x as shown. Also state the coordinate of the y-intercept. Just wants the zeros. The zeros always happen here, where it crosses the x-axis. So we've got one here, and here, and here. And it looks like our lines are at 5. Oops, sorry, I didn't mean to flip it. So this would be -1, 2, and 4. And then the y-intercept, this one's a little hard to read on this graph, but it looks like it's here. And it should be pretty symmetrical, so like where it pulls away from the graph, yeah, it should be like in the middle there. So that looks like that's at 8. So our zeros of our function are -1, 2, and 4. And our y-intercept is 0, 8. The zeros can also be written as points. Just pay attention to what the directions ask for. This one doesn't specify. If I had to write it as points, I'd write -1, 0, 2, 0, and 4, 0. Either way is fine. Find the zeros of the following function. That's a fancy way for saying solve it. So we're assuming that this is 0. And we want to find out where this equation equals 0. So I'm going to add 48 to both sides. Cancels, 48 equals 2x. X equals 24. This is a linear function, you can tell by the highest power, which means that there's only one 0. Or I should say at most. I shouldn't say only. I should say at most 1, 0. At most 1, 0. Because of the fundamental theorem of algebra. Find the zeros of the following function. So we set each of those parts equal to 0. So we have 0 equals x minus 3, 0 equals x plus 5, and 0 equals x plus 13. Add 3. X equals 3. I just flipped it around. I like my x on the other side. Minus 5. X equals -5. Minus 13. X equals -13. So those are our 3 zeros, and I can write them as one statement by writing x equals -13, -5, and 3. Most people don't care what order you write them in, but I like them like that. All right, find the y-intercept of the function. That's easy. Y equals mx plus b. B is -48, so our y-intercept is 0, -48. If you didn't know that, you know that the y-intercept happens when x is equal to 0. Right? The y-intercept happens when x is equal to 0, and f of x is a fancy way of writing y. So really y equals 2x minus 48. Y equals 2 times 0 minus 48, and we get y equals -48. Find the y-intercept of the following function. Okay, so the y-intercept happens when x is 0, right? When x equals 0. So instead of multiplying this out, which you could totally do and then take the last number, which is going to be longer, instead I'm going to find g of 0. So I'm going to do 0 minus 3, 0 plus 5, 0 plus 13. And so I end up with the numbers -3, 5, and 13. And I multiply those together. So g of 0 equals, now I gotta put it in the calculator. All right, -3 times 5 times 13, -195. So our y-intercept is 0, -195. I haven't missed anything, right? Yeah, no, we're good. We're good. We're moving. Use the graph of the function. Identify the intervals where the function is increasing and where the function is decreasing. So is it going up from left to right, or is it going down from left to right? So the first thing I'm going to look at is these, what they're called points of inflection. So they could either be zeros or just like points where things change directions. And so if I get real close to this graph, I can see here at -1, right? I switch directions. So my function is going down, 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 right? It's decreasing, 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 decreasing until I get to -1. And then I kind of like pan out and I'm like even level here. And then I start going up again. And I go up again until I get here to this point. And then I start going down again. And the next time I start going up again is at 2. And then I go up infinitely. So what I'm looking at here is I've got an area of decreasing here, and then I start increasing for a little bit, and then I start decreasing again until here, and then I'm increasing infinitely. Okay, so I'm decreasing in the following intervals. So this is x is -1. So that would be I'm decreasing from -infinity all the way to -1. Now I put a parenthesis at -1 because I'm not actually including that point. At -1, it's neither increasing nor decreasing. It's just staying constant. So we're not actually including -1. Then the next spot of decreasing is from 0. Again, we're not including 0. Right, because it's neither increasing nor decreasing. From 0 to 2, it's decreasing. And then it's increasing in the alternate areas. So it's increasing from -1 to 0. And it's increasing for everything after 2. So 2 to infinity.